I hope you can hear me. You've heard about our company, YADRO. We are a hardware developer, including hardware and software suites. We develop individual softwares as well. But since we're speaking about the architecture of IT systems, I don't think it's too good to speak a lot about the security standards for products. These are pretty standard. So I'll be speaking about preventing our products from becoming the source of data leaks. Here is what our company does. We have several business lines. We do base stations, semiconductors, OSs, client systems. You can come up to our booth and look at YADRO, but one of the core business lines for us is corporate infrastructure solutions. So these are not consumer products, not a server that you would have at home in your closet. These are large-scale, corporate-grade enterprise systems, 125 gigabits, storages for petabytes of data and servers, where it all gets computed. Here are the expectations by the customers from us. If they are to set up a reliable information system, as an enterprise class product developer, we aspire to become something like bloody enterprise. First and foremost, it's all about integrity, where we guarantee that the data that we operate with, store or process at our services, go through our switches, do not get lost, corrupted, or spoiled in any way. Then you have availability, meaning that the service that we provide, or our customer provides based on our service, or where they store their data with our warehouses, needs to be available at all times. Our goal is 100%. We do redundancies and other measures to ensure availability. The third point is confidentiality. The three pillars of security: integrity, availability, confidentiality, which means confidentiality that the data will not be accessed by those who are not authorized. All data in our warehouses are under restricted access. Access is controlled, and we guarantee that there is not going to be a mixing of data between different users. Last but not least, point 4 is that we are capable of properly maintaining our systems. It's critical for infrastructure, and especially so for critical information infrastructure. This is for IT systems to be maintained, updated, updating the drives, the firmware, individual components if need be. Our products are tailored for convenient maintenance. And these 4 parameters fit pretty well into the Western approach to reliability. I'll be speaking about software reliability, dependability. Software dependability. We do software which acts as firmware for our servers, which relies on 6 attributes. I've covered some of them: reliability, and integrity. And then you have additional things on top of that that would make up dependability for software.
There is this Frenchman currently living in the United States who has been developing his own theory of dependability since 1960s. Google it, it's a very good one. Now, next one is reliability. In other words, reliability describes the degree to which you can trust this application in terms of it, providing the correct results over a long period of time. That is sort of, being out there, working for you 24/7 without significant degradation. Something you must have also run across in your life is safety, and this is something that few people take seriously. Take, for example, Microsoft Windows. I think everybody knows what BSD is, blue screen of death. Now, BSD obviously shows that they didn't care enough about safety. If your application can, if an application can actually wreak so much havoc in the operating system, it means that in terms of safety, both the application and the operating system are not serious enough. So, safety is effectively about not creating any fatal flaws or catastrophic effects for the users. When, for example, your software kills the operating system, or your software makes your computer catch fire. So these were the attributes of software dependability. Again, dependability is a pretty well-known notion. It initially originated with ICS, or industrial control systems, but then you will also need the notion of dependability in software. And the KISS principle, keep it simple, stupid, or rather, keep it simple, is something that certainly applies very well here. The formula that applies very well here is like this: like the more complex your formula is, the more ingredients there are to it, the lower will be its dependability. So it could be a particular component or the whole system operating in a manner that does not result in any issues. So this whole theory of dependability was developed in the early last century.
Вероятности безотказной работы всех составляющих ее компонентов. То есть, чем проще компонент сам по себе, тем его легче.
So the simpler a subcomponent is, the easier it is to test it, to analyze it, looking for flaws. So if you create a system made of simple atomic components, the more dependable it will be. Now, if you use more complex components, which could be seen as systems in their own right, the same formula would certainly apply to them. However, we all understand that probability here, or like probability of dependable operation, just like all other probabilities, will be below 1. So the more ingredients you bring into the soup, the lower will probability go. So, naturally, you shouldn't create extras if not needed. Now, for the physical components, we often talk about this mean time between failures. So, this is what you do at so many test benches, for example, where, you put your equipment in salty fog or whatever, you run it until it fails under different strenuous conditions. And what we do to software is dynamic analysis instead. And dynamic analysis lately has been very much related to ECL, which is secure development of software. And this is something that we are going to talk about very soon. But let me start with some basic ideas. So naturally, we are developing software and hardware suites. And, even the simplest server is irreducible to the hardware itself. Well, naturally, it runs BIOS, and enterprise level servers naturally have BMC to them as well. Well, because you want to be able to manage all the components, and this is the element you use in order to manage your server so that you can switch it on, you can switch it off, you can check its console, you can install a new hard drive, and so on. Now, to make fun of some Oriental concepts here, I'd like to say, and if you like to make fun of humans, we can say that hardware is like the body, while the software is like the spirit. And people often say, well, we gotta pray that there is healthy spirits in a healthy body. So we need to make an effort to ensure that this is the case, that you indeed have a healthy spirit in a healthy body, that both the software and the hardware are of good quality and reliable and dependable, which obviously is something that we're trying to do.
по нашей
Now, a recipe of a high-quality product, as we see it, is like this. A developer of an information system will have their wishes and expectations.
управление там разработкой ПО, это
When it comes, for example, to software development, these are usually called user stories, or if you like, usage scenarios. So these are the things they would love to get once the system is up and running. So when we design the product, naturally we start asking ourselves where it's going to be used and how it's going to be used. And we build into the architecture of this product the expectations that, well, the client has in terms of security, dependability, and naturally we try to strike some balance between all this and the costs.
мы вкладываем в наш рецепт.
Now, the second principle that we build into it
На наш сайт
is being constructive, or we call it constructivism. Actually, in our website, you should be able to read a pretty long text on it all. Now, the idea there is that the function should drive the shape or the form of the product. Now, what does it mean in real life?
такую поговорку английскую done and done
You
well.
can
То есть это то, что
actually think of this English saying, done and done well. This is something that the God said on day 6.
мы смотрим на какое-то решение и видим, что оно красивое.
Same applies here. If you look at a solution and you see how beautiful and elegant it is, you probably say to yourself, done and done well. And this is a good indicator that on the constructivism side, everything is indeed properly done. Next one is functional minimalism.
компонентов.
I've already said that the fewer components you have, the better for the system dependability. That's why we are trying we're trying to stick to the Occam's rule.
Мне очень оно нравится, называется KISS.
I really love the KISS rule. Keep it simple, stupid.
Максимально простые, понятные решения, потому что
So we do try to apply the simplest, the easiest to understand solutions. It's easier to test them.
намного проще войти в работу и
If new people come in,
вот. И с другой стороны, чем меньше функциональной избыточности, тем меньше каких-то компонентов, тем
so I'm sorry,
версия атаки.
the more components there, the lower will be dependability.
Используем две функции в наш продукт. Ну, мы сделаем эти две функции часами, потому что непонятно, что мы с
So
этим
we'd rather develop these two functions on our own.
вливается в инженерную культуру. То есть
So all this gives rise to a particular engineering culture.
то, что вот раньше называлось именно industrial programming, то есть
So
промышленный
this is something that previously was called industrial programming.
и софта. Об этом чуть дальше. Про софт, про железо.
I'll get back to
Еще
it.
рассказывать.
We'll hear about hardware separately, and I'll get back to software.
Конструктивизма, который есть вообще в
Here is a bit of constructivism as manifested in architecture and technology.
Это
The
изображение
larger picture
завод.
shows a
В Москве, по-моему, тоже
bread
подобные были, по тому же проекту
plant.
сделаны. Это
It's in St. Petersburg, and similar
конвейер.
bread factories were built in Moscow as well. The conveyor belt was circular and it was highly automated. I think 8 of those were built,
В хлебе для
and they've
Московской
covered
области, части Московской области,
the
Питера,
demand for bread in Moscow,
на Кушлевке
St. Petersburg, and their respective regions. It's still available in St. Petersburg. It survives till this day. And this is an example of constructivism,
внутри такой
where
конвейер. И,
the shape or the form is determined
вот. Ну и
by the
второй
function,
хороший
and it looks elegant as well.
функция определяет форму.
A second example, a very good example, is aeroplanes.
Есть требования к аэродинамике.
The function is to
Напрямую
fly up and
эти требования.
fast.
То есть это вот как
This
раз,
puts certain requirements to aerodynamics, and the form manifests these requirements.
не раз. Есть такой традиционный
And then
процесс разработки ПО.
You've seen this many times, this conventional approach to software development,
Классика, да? То есть когда там нам надо выпекать
Hodgepodge
пирожки, как можно
release
быстрее,
production,
потому что там
where you need to do things as soon as possible.
хотят всего срочно, там новые функции.
Product managers have a lot of sales managers, new customers. They need all the things all at once, and they don't have money to do testing.
Клиент нас потестит.
So let's leave testing to clients. You've seen websites like this, of course. Even big company websites where you have a lot of bugs.
Надо сначала пнуть ежа,
Then
который птица гордая, сам не летает.
you
Вот.
need to complain a lot for this
Там посмотрели,
to
проверили вашу
get
ошибку и исправили в этом.
redone.
То есть это такая дурная практика, когда тестируют на
And
кастомере.
this is certainly poor practice if you're testing your stuff on customers. Now, the next important bit is documentation. This is something that gets deprioritized in most cases. People say, well, we'll do it later, and this later never comes. As a result, we experience lots and lots of issues. When salespeople, when project managers want to have more features in the products, these features come into conflict with each other. When we don't have documentation, we get no clue how one feature is going to impact other features, which is a disaster because this translates into lower dependability and security of your products. So there is a feature in the previous release, and then, several releases later, it sort of, drops between the chairs. Now, what's worst for the development team is that, you will have those prima donnas or owners of sacred knowledge. These people believe they know everything, and they indeed know a lot. And the newbies sort of follow them, asking them, and how does this thing work? And what about that thing? Because there is no documentation. So they do appreciate feeling special. Also, you get, those developers who develop something without ever thinking about how this code will be working, how it will be applied in a specific context. And they don't seem to even care. Surprisingly, this is not something they teach at universities. Now, the disadvantage for a business is that such attitude, garbage in, garbage out, it's in production, is such that, everybody's busy, a new person joins the team and they don't even know what to do because there is no documentation to study, and the prima donnas are too busy developing new features, so the new employees do as they know best, and then somebody needs to step in and correct their mistakes. So initially, it sounds like a good idea because, you work fast this way. However, you have to pay through the nose for those mistakes later. By the way, since we're here at Positive event, we swear by a process called SDL, Secure Development Lifecycle, or Software Secure Development Lifecycle. So if you can equate SDL with SSDLC, it's also part of the engineering culture, and it includes lots of different things. There is, in fact, a whole GOST to be updated very soon, like your symbol has been somewhat involved in the development of the new version. But what matters is that SDL is a kind of superstructure on top of the life cycle of your regular products. And we start by identifying all the expectations and wishes. So this is the planning and design stage. Going forward, we assess the risks. We develop a threat model, a threat actor model, just exactly like you would do developing an operating system. Naturally, you should not develop an operating system without thinking about the risks and the threats associated with it. This is true both for software and hardware. We also describe usage scenarios. And we also design high-level architecture. So indeed, we design it so that it's not functionally redundant, so that all the components we use are the ones that we actually need for this particular product. So high-level architecture, once it has been developed, we develop a high-level design. And in this high-level design, we describe every function at the level of specs, and we compare it to user stories or scenarios of usage. And this helps the testers immensely, because when we have those usage scenarios, testers will know what exactly to test for.
связываем это дело все с кодом. У нас
Next, we link it all to the code.
всем понятен, ясен, документирован.
And actually, this code is easy to read, it's well documented, and then we
Исходного кода нас
expose it to static analysis. That is, we check it for various constructs that can result in errors going forward. For example, those related to InfoSec, because naturally code will contain a certain share of mistakes. It was previously believed like 1 line per 1,000 lines of code is sort of okay. Now the engineering culture says, well, in all probability, it's more like 5 mistakes per 1,000 lines of code.
дело к тестировщикам, потому что
Okay, next we call in the testers because we've tested the static code. We have identified all the faulty or potentially dangerous constructs. Next, we got to do the dynamic testing. And we use test benches to do that. In the test benches, we will be testing both the algorithms and we'll also do fuzzing and unit testing.
О, отлично. Вот. Ну,
Do many people know what fuzzing is?
напомню, это такая штука, раньше был термин «профессиональный дурак». То есть человек, который
Now, there was this notion of a professional idiot previously.
Вот. А сейчас такой процесс автоматизирован. То есть мы имеем
Now, this
механизм
process has been automated. We have tools now
на
that enable certain algorithms that we run
специальным образом сконструированные данные,
kind
которые
of feed specially constructed data
максимально глубоко
which will mutate in order to
он может свалиться.
go inside the algorithm in a particular way.
Если у нас тесты фазинговые, фазинг-тесты
So,
работают долго, там
If our fuzzing tests are run, say, for several million launches and they give us a 50% coverage of the code, well, this tells us quite a lot about the quality of the code, doesn't it?
у нас не бегают
And finally, our engineers
знания.
do not go chasing those prima donnas. Instead, they read the documentation and they work, quite efficiently because of that.
То есть, ну, во-первых, я уже говорил,
So how do we design architecture?
использовать симагутеры,
We should not
которые
be
делают
using those, huge frameworks that will perform like 500 different functions out of which you only need 2. That's too much because if you use them, you're going to bring into your code lots of things you do not understand and maybe even aren't aware they're there in the first place.
заказчику абсолютно по барабану.
Clients do not really care
Потери данных.
whether a problem occurred in the storage, for example, because of an error in the code developed by the vendor or an error in the code which started out being open source. Like if you bring something that's open source into your product, you're responsible for it. So the less you import, the lower will be your attack surface, so to speak, your responsibility surface.
Правильный инструмент для решения правильной задачи. То есть,
Also, use the right tools to address the right problems. So, for example, if you have a system for logging security events, consider the mechanism you're going to be using. So you can use, say, your own CovDB distributed tool, proprietary, or you can use rsyslog or journal.de, something that you can easily find on regular Linux, and you don't need to have anything proprietary.
сценарий использования
You also need to consider the kind of usage scenarios and the kind of methods you will want to use to implement these scenarios.
я показывал раньше.
Now, the formula that I previously showed
Мы отдаем предпочтение
with this multiplication of probabilities, it naturally follows that we prefer to go for components that are simple and that are not too dependent on the others. So, for example, if one component goes down, it should not destroy the operation of the whole system. Naturally, there will be exceptions, but we'll try to design the whole architecture so that it's as stable as possible, even if some individual component goes down. I've already mentioned open source
который к нам входит в наш продукт, в наш
consideration, so to speak. I do believe that, anything we put in the firmware of our storage systems, well, if it's, open source, well, we should know very well what it consists of so we can patch it, we can maintain it.
какие-то баги, например, исправлять.
And actually, we'll be talking to, the upstream colleagues if it's open source, and we'll tell them if we discover something so they can patch their stuff as well.
И эстетичного взгляда,
So as far as engineering culture is concerned,
таким образом спроектированную архитектуру, оно
when you look at architecture like this, it is certainly elegant in a way that's done and done well is.
архитектура
It's an indicator of a job well done. This is what we call an elegant architecture, nicely documented, beautifully designed, neat diagrams, clear understanding of what is done by each and every component. Something else. Now, we know each and every byte in our products. So, some tools that we have are called SCA. Now, these are the tools that analyze all the components in our system. So, for example, if we're using a particular programming language like a Go, it will have the so-called transitive dependencies. So we take out of the network or a local repositories, some components, and we should analyze all these components for vulnerabilities. So this is something that we also do. So if we were not the ones to write the code, we will still need to do vuln analysis across all the components, including external ones. And the next 5 minutes will go towards discussing documentation. Everybody believes that doing documentation is difficult, but this is not necessarily the case. Now, the first thing you need to document is architecture itself. Now, there is this concept among architects that if your architecture is not documented, you don't have it. There is no architecture. So whatever you develop, an information system, a piece of software, or a piece of hardware, you gotta start with architecture and you gotta start with documentation. So I've mentioned already high-level architecture and high-level design. I've mentioned, the specs and at least a memo which describes the usage scenarios. And what's really key here is that if you have described the architecture of information system or a product, it should be easy to understand for any reader. In order to get there, we apply the so-called C4 model: context, containers, components, and code. It's a kind of a compromise, it's a kind of a trade-off between readability and level of detail. I used to see A4 lists which have like 50 different building blocks with 160 connections between them, and it's very difficult to navigate, to find your way around it. Now, C4 helps you avoid that. So you can check out a website called c4model.com, and there you will find the preamble, like an explanation where it came from, as well as examples of how to do it. And I certainly recommend. It's a very good model indeed. Also, we can assure kind of a traceability, so you can see how wishes and expectations got turned into code. Now, we can do that for every element of the code. Like, we can easily see how an individual wish or expectation or requirement got translated into the code. So we know where to look, and we can quickly find the root of the problem if problems arise. Now, what's more important for software is the so-called architectural decision records log. It was developed or promoted rather by Martin Fowler. And another one is what I've been previously calling specs, but in fact I'm referring to RFCs, or requests for comments. RFCs are a building block of documentation. So we make a decision that this is how we're gonna do a particular element of the system, and we consider different options to do that, pros and cons, and then we bring together our council of architects, which decides on the best option, something that will have minimum influence on the other components of the system, and then we develop the RFC, or if you like, the specs. And then programmers turn it into code. Now, programmers, like I said, develop code, and then somebody needs to do the documentation because the code needs to be properly described. So something that's happening quite often is that people do comments in the code, but that's not really nice, right? It's, these comments are only available to the software developers themselves, and it's only done because developers really hate writing documentation. They love writing code. They're usually good at that, I would say usually because there are some software developers out there which are not very good at writing code, but I hope you don't have those. Now, engineers and architects really hate, those office software. They don't like using their mice. They prefer typing everything away. So that's what we got to contend with. And naturally, a technical writer will not be able to produce content instead of your engineer, unless your technical writer is really, really talented and, in fact, they are more of a QA engineer or software developer, meaning they're not really a technical writer, which means that we need to make sure that our engineers produce documentation as long or during writing the code. So there is this methodology called documentation as a code, where you teach your software engineers to distinguish content and the packaging, so to speak. Secondly, you have your programmers, write, a portion of a CLI code. Maybe, they change the way that a particular command works. And in the same repository on Git, they should introduce a change in the Markdown file using the same editor they use for the code, which is good because you don't forget anything. You've made all the changes to the code, you've made changes to the documentation. And a system that helps you sort of distinguish the content and the Markdown is called Ditto, but there are others as well. Previously, there was also a thing called Dogbook, and all FreeBSD documentation is based on it. But Ditto is really good. It's Darwin information and so on and so forth. So it helps you develop a template for your document and stuff it with different building blocks produced by different architects and developers, while a technical writer will then be combining the whole document. Pick and choose, so to speak. So this way, the GOST that we have for software documentation is effectively, one of the formats you can use. So if you apply it, you can use, the methodology I've just described. And this makes your life so much easier. Or you can use a different template, and you will have a document which is good for your website, or say a beautiful user manual. And all this requires just a single DocOps engineer for a team. Now, a DocOps engineer is like an advanced technical writer. So DocOps are the people who know how to kind of semi-automate it. So, with your build, you are also going to have up-to-date documentation, matching it all. It's easy, it's fast, and it saves you the trouble of producing documentation 6 months later when nobody really remembers what you did. We love this approach. We recommend everybody uses it. Now let me show how it can be applied in real life. So there is the text itself, Markdown I think everybody knows, and GitLab, GitHub. Now there is also diagram as a code. As an architect, I really love it. So what you see here is the initial code, and on the left you see this diagram. And this is context, level 1 of the C4 method I previously mentioned. It's so easy to use it in the version control system. It's so easy for you to see what has changed, for example. So for somebody who's using it on a regular basis, all you got to do is just read the code to see what the connections are gonna be like.
You can see all the versions like you do on Git. Last but not least, here is the samurai's, or actually an engineer's journey. That's how to train people to adapt to this process, to clearly express their thoughts, to document all this, to code, and to come up with quality products. Over the recent 30 years, a lot has changed, and we've lost some things. The Soviet School of Engineering went away. The world has changed, so we are actively engaged with higher education, with the lectures at ITMO Technical University in St. Petersburg, at Moscow Fistech, LETI in Moscow. So we try to bring up our own engineers for the future. So secure development, documentation as code are covered at our lectures as well. We have joint labs across different streams. The QR code is available. We are open for internships this summer or next summer if you are not able to enroll now. We have this portal, which is also great. An eager engineer. It's all public, where engineers, true experts, explain various complex systems. It includes a design of processes. RISC-V, for example, on Monday there is going to be a meetup of RISC-V Alliance. And it has a lot of materials, QL, Go, C++, a lot of activities that are freely accessible. I think that's it from me. Thank you.